Welcome to Solving Multi-Step Equations. So please follow along on your paper. I apologize if there are no lines. I did write this on paper with lines. So if you want to do it on lined paper, I completely understand. Or if you want to pause the video and draw yourself some lines, you may choose to do that as well. So a reminder that when we're solving multi-step equations, order of operation occurred to get this end result, to get that number 13. So if we're trying to find out what x equals, we're going to be undoing the order of operations or working in the reverse order. Now, if we have any parentheses for distributive property, we are going to still do those things. Exponents, same thing. We are still going to evaluate those if it applies. But for the multiplication and the addition subtraction pieces, order of operation happened, we're going to go in the reverse. Okay, so we're going to start with any adding or subtracting that needs to happen first, and then go to the opposite for multiplying and dividing. Also, we want to make sure that we're keeping our equation balanced at all times. So if you need to draw a little line from the equal sign so that you're doing things on the same side of the equal sign, that might be a good strategy. So I see I have minus 2 right there. So the opposite of subtracting 2 is going to be to add 2. And subtracting 2 was the last thing that occurred because order of operations said whatever x was, it was multiplied by 5 first, then 2 was subtracted. So to undo that, we are going to add 2. We're going to add 2 to both sides so that we are keeping a balanced equation, doing the same thing to both sides. So this is going to cancel out. That's going to become 0. I have 5x on this side of my equation, and I have 15 on the other side, still equal. Well, if 5 times some number was 15, if I'm trying to undo that, I'm going to divide by 5. Divide by 5, divide by 5. 5 divided by 5 is 1, and the identity property says that 1 times anything is itself. 15 divided by 5 is 3. I can now go through and check my work to see if this works and say, is 5 times 3 minus 2 equal to 13? Well, order of operations, I'm going to go in order now. I'm going to start with my multiplying. 5 times 3 is 15 minus 2. Is that 13? 15 minus 2 is 13, so yes, this does work. Let's take a look at the next one. It says 4 minus x equals 10. Now I know this looks like a one-step equation, but when your variable is negative, in this case, as in this case, or at least having the variable on the inside of the operations, then this is indeed going to be a two-step equation. So I need to ask myself, what is the 4? Well, the 4 is positive. Even though subtraction is going on here, the 4 is positive. I need to get that to 0. How do I do that? Well, I'm going to minus 4 from each side to get that to 0. Okay? I know some of you are going to want to try and add 4. No, no, no. We're subtracting 4 from each side. So now I have to bring down my x, but this is a minus x, a negative x. Because remember, if I were to do a keep, change, make this addition, that x is really negative, okay? So, excuse me, 10 minus 4 is 6. But I can't end my problem with a negative variable like that. So what number is really in front of the variable? What's the coefficient here? Well, there's this invisible 1. So how do I get rid of an invisible negative 1 in this case? I'm going to divide both sides by negative 1 because a negative divided by a negative is a positive. So now I have x is really equal to negative 6. So I want to check that to see if it works. So I'm going to plug it in. 4 minus negative 6, I want to know, does that equal 10? All right, and I'm just using some parentheses. I know they're not in the original problem, but just so my minus and negative sign are not right next to each other. So I've plugged it in, and now I'm just rewriting it. Now I can do my keep, change, keep the 4, change to addition, change my negative 6 to a positive 6, and is 4 plus 6 equal to 10? Well, yes it is. So that works. All right, let's take a look at the next problem. So here I see that this has more terms in it. The other two problems each had 2 terms on the left side and 1 term on the right side. See, here I have 3 terms. So, and I see that both of these have an m in them, which means that they need to be combined. This one does not have a coefficient or number in front of it, so I know that that really means there's a 1 in front of it. I'm going to simplify this first. 1m minus 5m, well, that's going to give me negative 4m. Plus 3 equals 47. Now this looks like it's in the structure that I've done several times before. So I know that order of operations said that the plus 3 was the last thing to happen, so I'm going to minus 3 from both sides of my equation. I think I'm going to draw my dotted line down here again. So that leaves me with a negative 4m on this side, and 47 minus 3 gives me 44 on this side. Now I see that multiplication was occurring, so the opposite, I need to divide. So I'm going to divide both sides by negative 4, and I get m equals negative 11. Well, now I need to check that. So I have 1 times negative 11 minus 5 times negative 11 plus 3, and I want to know, does that equal 47? All right, well, this one's a little more complicated than the others. Well, this gives me negative 11. 5 and negative 11 give me, so minus negative 55, I'm going to put those parentheses in, plus 3. And we're checking on 47. Okay, well, that's a little complicated. But I'm going to do I'm going to rewrite it. And I'm going to do my keep, change, change. Keep negative 11, change from subtraction to addition, change from negative 55 to positive 55. All right, well, that works now. So now I have negative 11 plus 55, and I know that means in my head I'm going to subtract because I have a negative and a positive. They're different signs. I'm adding, so I subtract the numbers in my head. It's going to go down. This negative means it's going closer to 0, starting at 55, going closer to 0. So that's going to be positive 44 plus 3. And does that equal 47? Yes, 44 plus 3 equals 47. So this one does work. All right, are you with me? If you are, great, let's move on. If you're not, go ahead and pause and go back to see what you need to hear again. All right, moving on. So we have, notice these are now division problems. The other ones have multiplication in them. And we have our 2 sides here going on with our phrase, all right? So I think I'm going to put my little line down. And let's see. Last thing that occurred was actually this plus 15. Again, we're thinking of that order of operations. So if a plus 15 occurred, I need to subtract 15 from both sides. When I do that, I'm going to bring down my c divided by negative 3. And 8 minus 15 gives me 7. Well, I see that division is occurring, so I need to do the opposite operation. And the opposite of division is multiplication. Now, am I going to multiply by the 7 or am I going to multiply by the negative 3? I'm going to multiply by negative 3 because the c is being divided by the negative 3, and that's what I'm trying to get rid of. So I multiply both sides by negative 3. And this is really negative 3 over 1. These are going to cancel out because there's really a invisible 1 here. 1 times negative 3 is negative 3. Negative 3 times 1 is negative 3. Negative 3 over negative 3 is 1. Negative 3 times 7 gives me negative 21 here equals c. Now I want to plug it back in and check to see if it works. Negative 21 over negative 3 plus 15. Does that work? I have to follow order of operations, which says I need to do my multiplying and dividing first, right here. So, let's see. Negative 21 divided by negative 3 gives me a positive 7. Positive 7. And then 7 plus 15 doesn't give me 8. All right, so that tells me I've made a mistake somewhere. So I'm going to look back at my work and see, where did I make a mistake? Oh, look, I see right here, I said 8 minus 15 is positive 7. That's really negative 7, okay? Which means that this negative 21 is really positive 21, okay? Which means that this is positive 21 there. And so now I have positive 21 divided by negative 3, so that gives me negative 7. Okay, now this is going to work. Negative 7 plus 15 does give me 8. Notice that's something real easy to forget, but by doing the check, I found my error. So it is very important to check your work. All right, next one. So I have k divided by 5 minus 10 equals 3. Minus 10 is the last thing that occurred, so I'm going to do the opposite. I'm going to add 10 to both sides. That gives me k over 5 is equal to 13. So some number divided by 5 equals 13. Well, in order to figure out what that is, I need to multiply both sides by 5. And I get k equals, let's see, 5 times 3 is 15, carry my 1, 65. So now I need to see, does that work? So is 65 divided by 5 minus 10 equal to 3? Well, let's see. I'm going to do my multiplication and division piece. So 5 goes into 6 one time with 1 remaining. 5 goes into 15 3 times, so that should be 13. 13 minus 10, is that equal to 3? 13 minus 10 is equal to 3. So yes, that works. Last problem. Little out of order, but I know that the addition subtraction piece, the number that is not attached to a variable, is the last thing that occurred to get this 35. So I need to minus 3 from both sides. This is a positive 3. The only way to get rid of it is with a negative 3. So 35 minus 3 is equal to 32. And then I have t over 2. So some number divided by 2 equals 32. Wow, the only way to get that is to multiply. So I'm going to multiply by 2, multiply by 2. And I'm going to get t equals 64. So now let me check it. 35 equals 3 plus 64 over 2. All right, I'm going to follow the order of operations now in order to check it. 2 goes into 6 3 times, and 2 goes into 4 2 times, so that's 32. Plus 3, is that equal to 35? 32 plus 3 is 35. So this does work. All right, so there you go. Some two-step and multi-step equations. This is just the paper pencil piece of this concept. We still have a lot more to do with it, and you are expected, or will be expected, to be able to write problems based on being given the words and scenarios, not just only the solving piece, but this piece is just as important as well. So thank you for joining me. If you don't have it all, please rewind so that you can get the missing pieces, and have a great day.